Hi friends, in this video we are going to solve this example. F of x equal to 1 minus 3 in bracket x minus 1 to the power 2 by 3 on closed interval 0 to 2 and f of x equal to mod x. Check the given function satisfy the condition of Rolles theorem or not. So here first given information, here I will solve the question A. Given f of x equal to 1 minus 3 times x minus 1 to the power 2 by 3 defined on the closed interval 0 to 2. So here this is the given function. So check whether this function satisfy the condition of Rolles theorem or not. So here this is the given function f of x equal to 1 minus 3 times x minus 1 to the power 2 by 3. This is defined on the closed interval. So here first condition of the Rolles theorem says check whether the given function is continuous on the closed interval AB or not. So here f of x equal to first condition f of x equal to 1 minus 3 times x minus 1 to the power 2 by 3 being an algebraic function continuous on closed interval here 0 to 2. So here which is continuous on the closed interval 0 to 2. Now we have to check whether this function is differentiable on the open interval 0 to 2 or not. Here f of x equal to this, therefore f dash of x equal to, here derivative of 1 is 0, this is 0 minus here derivative of x power n is n into x to the power n minus 1. So here 2 by 3 times, here 3 x minus 1 to the power 2 by 3 minus 1. So here which is equal to, here minus 2 by, this is 2 by 3. So here 2 by 3 and this 3 gets cancelled. So this is minus 2 times, here x minus 1 to the power, here 2 by 3 minus 1 which is equal to, here 2 minus 3 by 3 which is equal to minus 1 by 3 which is equal to minus 1 by 3. So here therefore this is equal to minus 2 by x minus 1 to the power 1 by 3. So this is my f dash x. Therefore f dash of x equal to minus 2 by, here x minus 1 to the power 1 by 3. So this is my f dash of x. Now we can observe one thing, here f dash of x equal to minus 2 by x minus 1 to the power 1 by 3 at x equal to 1. So at x equal to 1 this belongs to this interval, x equal to 1 belongs to this interval, and at x equal to 1 this function is not defined. Therefore at x equal to 1 that belongs to the open interval 0 to 2, f dash of x does not exist. Therefore f of x is not differentiable on open interval 0 to 2. Here if the function is not differentiable on the open interval 0 to 2, then we can say the Rolles theorem is not applicable for this function. So here second property of the Rolles theorem is not satisfied by this function f of x equal to this. Therefore here f of x, therefore Rolles theorem not applicable for function f of x equal to 1 minus 3 times x minus 1 to the power 2 by 3 on closed interval 0 to 2. So here this function f of x equal to this is not verify the Rolles theorem. Now we have to check whether the given function 2, now I want to here verify whether f of x equal to, let's say b, here I will solve for b, given Here answer for B given f of x equal to mod of x, which is defined on the closed interval -1 to 1. So here we know that f of x equal to mod x, which is equal to here x when x is greater than 1 and minus x when x is less than 1. Here I am writing f of x equal to mod of x, which is equal to x when x is greater than 1 and so x when x is greater than 0 and minus x when x is less than 0. Now so this is my function f of x equal to this. So here first condition of the Rolles theorem says whether the function is continuous or not. Here f of x equal to mod x, here which is continuous, as modulus function is continuous, which is continuous on the closed interval -1 to 1. Here first condition is satisfied. Here second condition, we have to check whether the f of x equal to whether the function f of x equal to mod x is differentiable on the open interval -1 to 1 or not. Here you can just check left hand derivative at 0. Here check f of x is differentiable at 0 or not. Here check the left hand derivative of function at 0. Therefore check left hand derivative of function f of x at 0. So that is here f dash at 0 minus, which is equal to limit x tends to 0. Here f of x minus f of 0 divided by x minus 0 is 0. Now when limit x tends to 0 minus means x is less than 0, at that time tell me the value of here limit x tends to 0 minus, tell me the value of f of x, that is when x is less than 0. This is minus x minus f of 0 is 0 and this is minus x, this is x, which is equal to limit x tends to 0 minus, here minus x by x, which is equal to minus 1. Left hand derivative of your function f of x at 0 is minus 1. Now check right hand derivative of f of x, at 0, that is f dash of 0 plus, which is equal to limit x tends to 0 plus, that is f of x minus f of 0 divided by x minus 0 is 0. Here this is equal to limit x tends to 0 plus, here when x tends to 0 plus f of x is x minus, this is f of 0 is 0 divided by x, which is equal to limit x tends to 0 plus x by x, which is equal to 1. Here left hand derivative of this function at 0 is minus 1 and right hand derivative of your function at 0 is 1. Therefore here left hand derivative is not same as, here left hand derivative is not same as right hand derivative at 0. Therefore function f of x is not differentiable at 0. Therefore here Rolles theorem is not applicable for function f of x. So here for these two functions the Rolles theorem is not verified. So why? The first function a equal to f of x equal to 1 minus 3 times this, so which is continuous, but here f dash of x equal to minus 2 by x minus 1 to the power 1 by 3 and x equal to 1, this function is not defined, f dash of x is not defined. Therefore and x equal to 1 belongs to this open interval 0 to 2, and at that point this function is not defined. Therefore this derivative of your function at x equal to 1 is does not exist. This means that function is not differentiable in the open interval 0 to 2. So this means that Rolles theorem is not applicable for this function f of x. So according to working rule. Now come to here f of x equal to mod of x, which is defined on the closed interval -1 to 1. So here all of you know this function is continuous here, and f of x equal to mod x, which is defined at x when x is greater than 0 minus x when x is less than 0. Here all of you know this function is continuous on the closed interval ab. But now check whether this function is differentiable at 0 or not. Here check the left hand derivative of function at 0. F dash at 0 minus limit x tends to 0 minus f of x minus f of 0 by x. Here when x tends to 0 minus, at that time the value of f of x is minus x minus 0 by x minus x by x, that is minus 1. And check the right hand derivative of function at 0. F dash at 0 plus equal to f of x minus f of 0 by x limit x tends to 0 plus limit x tends to 0 plus x minus x 0 by x. Here x gets cancelled. This is equal to 1. Therefore left hand derivative of your function at 0 is not same as the right hand derivative of function at 0. Therefore function is not differentiable at 0, which is belongs to the open interval -1 to 1. Therefore Rolles theorem is not applicable for this function f of x equal to mod x, which is defined on the closed interval -1 to 1. Thank you.